This video is to help introduce writing algebraic equations from word problems. So this is really something along the lines of lesson 4.3 from the 7th grade textbook. And I introduced this kind of as a follow-up after our test or a quiz the other day over writing or over solving equations. And I understand that we didn't spend a lot of time talking about this because we ran out of time. It was not homework. So I do hope that you have it somewhere in your folder, your binder. If your guest teacher needs to call a quick timeout so that you can find this and get it out, that would be awesome. If you need an extra copy, you could definitely look in folder number 14. Again, our 7th grade extra copies in the back of the classroom in our crate. It's folder number 14. I do expect that you attach all work. And I do expect that if you already did this, that you can still be respectfully following along and making sure that you are in agreement and that you have followed the rules of writing an algebraic equation like I asked you to do. So creating algebraic equations before we solve them. So I do hope your name is already on this paper. I did give you a name line today. I know oftentimes we like to turn in our riddles with nobody's name. So take credit for what you do today. I know numbers 1 and number 2 are things that we have seen before. Those are really just solving multi-step equations, so I'm not too concerned there. I want to fast forward to number 3. I did have this example on the board the other day, but I want to break it into step 3 and see if we can kind of figure out where that information came from. So number 3, Jack said 5 times my age in 2 years is 100. How old is Jack now? Well, I noticed something. It says 5 times, but then it also says my age in 2 years. You need to recognize that your age in 2 years has to kind of happen first. Before I can multiply that times 5, I need to figure out how old I'll be in 2 years. So because we don't know Jack's age, we could use a variable here. We might say x. And because it's 2 years from now, we might say x plus 2. Now, that 5 times it, that really means 5 times the quantity or the total of his age in 2 years. I also noticed this word is, which is really my equal sign. It's really telling me here's the drawbridge. Here's where I separate one side of the equation from the other. Let's go ahead and write out what we have. 5 times the quantity of x plus 2 equals 100. Well, if you notice, there's a distribution that has to happen first on the left side. So it looks like I'm going to get 5x plus 10 equals 100. And if you want to isolate your variables, we're going to move the constants across the drawbridge to the other side of the equation, meaning you have to use an inverse operation. Well, you're left with 5x, and on the other side equals 90. If you were to isolate your variable one more step, we're going to divide by 5. To undo the operation of multiplication, we might divide. I also have seen some of you multiply by 1/5, which is the reciprocal, and that will also work as long as you show it on both sides of your equation. If you notice, I'm left with just one x, which usually we indicate just as x. And on the other side, 5 goes into 90, let's see here, 18 times. 5 times 10 is 50, 5 times 8 is 40 more. This looks pretty good. This looks like an answer. So on my worksheet, I'm going to transfer my answer. Notice I did remind you to do that. So not only can I write x equals 18, I might write 18 years old. I'm practicing giving words back. If I give you words, please give words back. Let's take a look at number 4. Let's talk about Jill real quickly. So the same process is true. It says Jill said 8 times my age 3 years ago. Well, before I can do much with that, I need to figure out how old she was 3 years ago. And before I can multiply that 8 times, I need to group it so that I'm thinking about that age kind of by itself. I'm trying to figure out her age 3 years ago. Because I don't know how old she was, I'm going to use an x, and because of 3 years ago, we're going to subtract 3. Well, this 8 times it really could look like a distribution, couldn't it? And I noticed the word equals this time. They didn't use the word is, they used the word equals. Oh, okay, we'll use an equal sign. And equals 104. I think we're ready to write this out. So this is problem number 4. I should see from you, 8 times the quantity of x minus 3 equals 104. You will want to use a distribution here. You will want to isolate your variable. You will be able to find a good answer, which then you should transfer back to your worksheet and also tell me what it means. meaning give me back some words. Okay? Let's take a look at number 5. So number 5, just to get you started in thinking along this line. It says, the length of a rectangular garden is 7 feet more than the width. Oh, it says the length is 7 feet more than the width. Actually, they showed me that. More than usually means addition. And in this case, that's what they showed me, x plus 7. This length is 7 more than the width. The perimeter is 50 feet. Find the width. Oh, here's a big hint. We're talking about perimeter, and they said the word is. So I know everything that I do here to find the perimeter is going to equal 50. Well, let's talk about perimeter. How do we find that? Well, usually we take 2 groups of the length and 2 groups of the width, and we add those together, don't we? So if this was my paper, I would say this is number 5. I have 2 groups of x plus 7, because that would be this top border and this bottom border of the garden. And I'm also going to add the width. Well, over here I have an x, and over here I'd have an x. That would get me 2 x's. When I'm done, I know that perimeter equals or is 50 feet, so I'm going to set that up as equals 50. If you notice, there's a distribution that has to happen first on the left-hand side. Then you want to combine some like terms, put together your x's, and then isolate your variable. When you're done, make sure you tell me what you got for an answer, and also what does it mean to you. Give me back some words, word form. Let's take a look at just a couple more and see if we can get you started so that you're off to a good understanding. Number 6, it says the length of a rectangle is 3 centimeters less than 4 times the width. Whoa, that's wordy. The perimeter is 114 centimeters. Find the width. Well, I noticed something. First of all, this important piece, perimeter is or equals 114. I'm going to have to list that somehow. And because it's talking about a rectangle, I probably would sketch this on my paper right about now. All right, I want to picture it a little bit. It says the length of a rectangle is 3 centimeters less than 4 times the width. Well, everything is based on the width. So if I were to label the width x, this would be a great start. It also says I want 3 centimeters less than 4 times the width. Well, remember these words, less than? Those are backwards words. You're going to have to be very careful here that we need to show 4 times the width first. So 4 times the width of x is 4x. And less than means I'm going to subtract. I need to subtract 3. That would be true on the top and the bottom of this rectangle. I think I'm ready to find my perimeter. So I have 2 groups of 4x minus 3. So I'm going to show 2 times the quantity of 4x minus 3. And remember, I can't forget to add those widths on. So I'm also going to add 2 times x, or 2x's. I need an equation. I'm trying to write algebraic equations after all. So I'll go back and notice it said this perimeter that I'm working on is or equals 114. Notice there's another distribution happening here on the left. There is a subtraction that you need to be careful about, and then you combine your like terms in a moment, not yet, but in a moment after your distribution is gone, and then isolate your variable. I want to believe that this is enough to get you going in the right direction. The only other thing I want to point out to you before you finish these up today is that right here on number 7, these symbols, we talked about these before. In geometry, when we have this matching kind of like this tick mark, it means that all those dimensions are the same. If there's just one tick mark, well, those are all the same length. So in this case, they're all x. Notice this. I'll use a different color to kind of highlight it for you. If there is 2x plus 1 on the top and they give it 2 little dashes, that means the 2 dashes on the bottom mean it's equivalent or congruent. So on the bottom, that's also a length of 2x plus 1. You're going to need that to set up your equation. You're also going to have to solve using your inverse operations, isolate your variable. I'm going to trust that this is enough to get you going. If you happen to get this done, that's awesome. Maybe you get to steal a few minutes of reading. Maybe you want to discuss it with a table partner, make sure that you are helping everyone out in your team to make sure that everybody has a good understanding. And in a moment,
we're going to try to move on and get you to create your own equations.